Do a brief introduction of David and Brian here before we get going. David Weum is a plan review engineer at MDH in the Drinking Water Protection Program. He received his training in civil as a civil engineer from NDSU and has been with the Department of Health for 10 years now, starting in the field as a district engineer for 2 years and doing plan review since that time. David serves as the Health Department Commission's designee for the Minnesota Plumbing Board and as Minnesota's representative for the 10 states standards Waterworks Committee. Don't try to say that very quickly sometimes. Brian is a graduate of the University of Minnesota and is a registered professional engineer in the state of Minnesota. He is currently a principal engineer at the Minnesota Department of Health, where he has worked there for 35. Oh, congratulations, Brian.
Thank
Brian's
you.
responsibilities have included 10 years in plumbing plan review, 21 years as a drinking water protection plan review engineer, and currently as a community water supply district engineer in Hennepin and Anoka counties. Brian also serves as the chloride engineer and cross-connection control lead engineer for MDH. Welcome, the two of you, and why don't you guys take it away? Looking forward to hearing about drinking water protection, something that I, as for one, need more education on. Thanks for being here.
Thank you for having us. As Mark said, I'm David Weum. Brian Noma is with us. We both work for the Department of Health in the Drinking Water Protection section, and we both have experience in the field as well as doing plan review. Throughout this talk, we're gonna try to.
David, can you speak up a little?
Here, we'll get the mic a little closer. Is that better?
Yeah.
All right. This talk, we're gonna try to cover a pretty broad overview of what surface level of what the drinking water protection section does. Brian will talk to you guys a little bit about the drinking water systems, surface, ground, get a little more details into there. I'll come back and talk to you a little bit about how plan review works for us for drinking water infrastructure. And then we'll close out with some shared interests between Department of Health and MPCA. And at the end, we'll have some time for questions if you want to dig a little deeper into any of those topics. So, Department of Health. Our primary responsibility is the Safe Drinking Water Act. That's a federal law, first enacted in '74, and it's been amended a few times, 86 and 96. Basically, so EPA gives the Department of Health primacy in the state of Minnesota to enforce the Safe Drinking Water Act. It regulates any water source that serves 25 or more people regularly. The 96 amendments was kind of the big one. It brought a lot of things in, like the revolving fund, operator certification, the consumer confidence report, which is that yearly kind of letter notification of here's what's in your drinking water, surface water protection, and like the surface water rule were big ones, as well as cost benefit analysis for MCLs, which I thought was interesting. I didn't know that was actually when that came into effect, but that's the big difference between the health risk limits that a different part of the Department of Health works on putting together and the maximum contaminant levels, which are the federally enforceable standards. Is the MCLs have a cost benefit analysis of, how much more money is it going to take to get to drop that, to treat that contaminant down to another level, and how prevalent is it, things like that. So
Could you still speak a little louder?
Yeah, I can certainly try to do that.
Like bring it up about 2 notches at least.
All right. So I didn't change around this slide quite as I wanted to. So I'm going to start actually with community and non-community. So both community and non-community have pretty similar functions, but they operate with different types of public water supplies. So a community public water supply, think about somewhere where people live. So it would be a city, an apartment with its own well, sometimes housing developments where they have a shared well for a number of homes, mobile home parks. That would be a community public water supply. A non-community public water supply would be somewhere where people don't live, but they gather together to either work or play or just some sort of gathering. Common examples of those would be like a church, bottling, meatpacking plant, a campground, a resort, somewhere where it's temporary and not the same people are going to be there all the time. So both the community and non-community units, they will visit those sites, all the sites in Minnesota that serve that function as a public water supply at least every 3 years, usually sometimes as soon as every year, to do what's called a sanitary survey. And don't get caught up on the word sanitary. I know I did at first when I was started, was thinking more on the wastewater side, but it's just a going through the entire drinking water system from the source to out to the distribution system and verifying that what they have in place and how they're operating their system is within accordance with the regulations. Our field staff will also go out and do sampling from time to time to help to verify that the systems are meeting the various rules for certain contaminants. And we have people within those units that are experts in those rules. So like the nitrate rule, the disinfection byproduct rule, as Brian introduced, chloride would be something he's responsible for, lead and copper, things like that. We have staff that are tasked with kind of being the expert, knowing those rules inside and out, and helping make sure those rules are enforced properly. And as well as our staff will get out there and give technical assistance. And this gives a lot of opportunity for our field staff to get out there with the systems and get to develop good relationships and get to know them. And that's worked really well for us. Something kind of unique that Minnesota does is that sampling by our own field staff. A lot of other states just require that the system themselves take those samples. But part of the reason we have such good compliance rate is because we go do that ourselves, and it also gives us more opportunity to develop those relationships so that the systems will reach out to us more often when they need that technical assistance or something else is going on. So the administrative unit, that's what I'm in. It's more supports the role of the other units. So we have operator certification in there, similar to wastewater operators. Our enforcement group for any sort of maximum contaminant level exceedance, or they're not, submitting plans before building things. Plan review, which is what I do. We have our database management folks in there that help because we have developed our own database and are trying to move to something EPA has in the future, but that takes a long time, as well as our drinking water revolving fund program, which is pretty similar to the clean water revolving fund. It's low interest rate loans for drinking water infrastructure. So back to source water protection. Their main function is, their name's pretty obvious. They're there to protect the sources of our drinking water. The big way they do this is they set up drinking water supply management areas. I got a picture of one here. I thought they were pretty interesting. So they'll find take the well, and then the red circles are a 1 year time of travel of anything on the land that happens within that red circle can impact the well within a year. The blue circle is 10 years. And then the yellow is like the legal boundaries that encompass the blue circle. So the yellow outline is their drinking water supply management area. And then source water protection works with the system to develop their wellhead protection plan for what they're going to encourage people to do or do themselves if they have the legal authority to within that area to protect the sources, their drinking water sources. potentially of interest to PCA. They also run a grant program for making those changes happen. It's $10,000. If it's within their source water protection or wellhead protection plan, I believe they just get it if it qualifies. If it's not, they can still qualify to a different one, which matches up to $10,000. And wellhead protection is also starting to get a little into surface water sources, protecting those, thinking on a watershed scale, as well as they've done a little bit of unregulated contaminant monitoring to try to keep us ahead of anything that may come down the line and surprise us. And from there, I'm gonna stop sharing and give it over to Brian here to talk with you a little bit about drinking water systems. Oh, I'm going too far ahead. All right.
Okay, thanks, David. So I'm going to talk about drinking water systems. I'm going to probably be a little heavy on the community side because that's where I reside. But in this slide here, you can see that we have two types of systems: surface water systems and groundwater systems.
You're not sharing it.
Oh, hang on. No.
There we go.
Is it up now?
Yep,
Yes.
looks good.
Okay. So two types of drinking water systems. We have surface water systems, so systems that serve their source water, get their source water from surface water, and then groundwater systems. So if you look at the numbers, community systems, there's 23 community systems in the state of Minnesota, but they serve 1.16 million people. So not very many systems, but lots of people. So what I usually tell people is the typical setup is going to be very large communities, and we'll kind of show that a little bit later. We also have 61 non-community systems, and so in the non-community realm, these systems typically are going to be up in the northeast portion of the state for resorts and businesses and churches and things up in that neck of the woods. And if you think of it from a geological standpoint, that area, the groundwater is not very prevalent, and it's not easy to get to, and it doesn't come in great quantities. So that's typically where surface water systems, you'll find those. Groundwater systems, on the other hand, you can see there's quite a few of them, over 1,000 community systems, over 5,000 non-community systems. And the number of people they serve, even though they probably serve smaller cities, they serve quite a bit of the population, probably double what the surface water systems serve. So.
Hey, Brian.
Yes.
You're just showing PowerPoint. If you want to go into slideshow mode so we could see your each slide a little bigger, that might be helpful for folks. If not, it's still fine.
Is it better now?
No, we're still seeing, the slides on the left there. It's okay. We can just keep going.
Okay. I just hit slideshow. Let's see. All right. I'm technologically challenged here. So.
Don't worry about it. We're fine. We can see a slide. We can hear you talk, so we're all good.
Okay. Okay, so for surface water systems, the sources we typically see are going to be lakes and rivers. Rainy River, Lake Superior, Mississippi River, Red Lake River up in the northwest portion of the state. Bud Lake I put in there because it's kind of the outlier. It's down in southwest Minnesota.
Brian, the slides you're sharing, it's not showing the slide you're talking about.
Oh, gosh.
Do you have two monitors, Brian?
Yes.
Okay, that's probably what the challenge here is.
So, all kinds of issues today. All right, there's my surface water slide. Can you see
There we
that
go.
now?
Yep.
Yes.
Sorry about that. Okay, so the sources, again, lakes and rivers. So I have a few of them named there. Bud Lake being kind of the outlier down there in southwest Minnesota. And again, northeast Minnesota lakes, areas geologically not rich in groundwater. So typical type of treatment is called conventional filtration, where you have coagulation. You make the particles in the water bigger. Sedimentation, you let them settle out. The ones that don't settle out, you'll filter them. And then you have to disinfect the water with chlorine or some disinfectant which does carry a residual. And then the important part there is the CT or disinfection time. So they're depending on the water temperature and a couple other factors. We look at making sure that it's disinfected properly before it's sent out into the distribution system. One of the kind of key things for surface water systems is they typically have to be built for redundancy, and that's so that the city or the place that it serves doesn't ever run out of water. So in this case, for a city like Minneapolis, St. Paul, or St. Cloud, you're building the plant twice as big as it needs to be for its highest demand day. So if you can imagine that most days, your highest demand day is probably going to occur middle, late summer, and maybe for a week or two at the most. So you're putting an awful lot of money into infrastructure that you may not really use, but you have to do it in order to keep a supply of, ongoing supply of water to your customers. There's significant regulatory reporting requirements as far as disinfection, biological, bacteriological reporting. Other things you're looking at, turbidities. So the reporting can get very cumbersome just by the sheer number of reporting of the data that you have to do to the regulatory agency. And so again, we look at population served. So we got the Twin Cities, St. Cloud, Duluth, East Grand Forks, International Falls, Fairmont, and then the resorts up in northeast Minnesota. So here's a map showing the kind of the overall distribution around the state of the different surface water systems. So I think the Fairmont one is kind of the outlier again, but it's in an area that maybe groundwater is not as readily available, or it may, if it is available, it might not be of enough quality to use as a source. But you see there's quite a few of them up in Northeast, some in the Northwest, and then along the Mississippi River. So I've got a picture here. This is the headwaters of the Mississippi River. This is where it's probably at its cleanest. If you think about it, if you looked at the other end of the Mississippi River down in New Orleans area, we always kind of like to joke that it's probably been in and out of at least 15 people by the time it gets to New Orleans. So. And then the other surface water picture that I have is Lake Superior, and so Duluth, and I think Beaver Bay is on this, a couple other systems up the shore, but pretty pristine and pretty clean source to start out with. So groundwater systems, so that's where most of the systems are going to have it, draw their source water from. It's going to be either glacial drift or bedrock aquifers. So for groundwater systems, some have no treatment at all, and it's and by that I mean there's like no filtration or anything else. They are required, so municipalities are required to feed fluoride, but other than that, they're not even required to treat to feed chlorine unless they have ongoing bacteriological issues. So so you could have some with no treatment at all other than fluoride, You could have chemical additions. So what a lot of systems do is they might feed polyphosphate to keep the iron, dissolved iron and manganese in sequestration. And then by feeding that, you are also required to feed chlorine. So because phosphates are considered a food for bacteria. So you might have systems as simple as a couple chemicals. The typical treatment, though, is going to be iron and manganese filtration, but you also will have advanced treatment. So city of New Brighton has a system to deal with dioxane, stuff coming out of the munitions area. There are several other areas, I think Edina and St. Louis Park, Spring Park. Those are area systems in my territory that I know have advanced treatment. But your typical treatment is going to be oxidation of the dissolved iron and manganese, filtration, disinfection, and fluoridation. Let's see. So again, the treatment plants are typically built to meet the maximum daily demand. So again, you're going to meet whatever the highest day you estimate for your system. So groundwater plants can be built quite large too, in the fact that they're probably not going to use they're not going to meet their maximum daily demand more than maybe a week during the year, but they do want to be able to provide water at all times of the year. The beauty of their system is they're not going to build it double the size that they normally would, and the reason is typically if the treatment plant was to go down or need to be taken down for a reason, a lot of systems have interconnects with other cities so they can get supplies of water from other cities. And then also if their source water, their ground source water is good quality, they can just pump their straight ground water straight into the system untreated as long as it meets the regulatory requirements. And so the reporting requirements for these are pretty basic compared to the surface water. There's not nearly the amount of data collection or monitoring. So there are some reporting requirements, but not a lot. And again, the population base served here is going to be typically the smaller population base, rural cities, areas that have plentiful groundwater, which is most of the state. And then, so water contaminants, talking about water contaminants, we're looking at, so in the surface water realm, we're looking at possible sewage contamination from discharge from sewage plants that might be either upstream if they're on a river, microbiological, so bacteria, viruses, and protozoa. Always constantly monitoring for that. Chemicals, herbicides, pesticides, chemical spills, chemicals being used upstream in industrial uses, and then algal toxins, which has been a more recent issue for with the weather patterns that we've been seeing, and then some petroleum, but the petroleum more is probably seen in the groundwater contaminants, where we have naturally occurring contaminants such as radium and arsenic, but we also have some man-made contaminations, volatile organics from spill sites or Superfund sites, PFAS compounds, and then petroleum spill sites, so old gas stations, buried petroleum tanks, etc. So, got a couple pictures here of just wells as we typically see them. So when we're out looking at these, we're just making sure that the well is constructed properly, setbacks to sources of contamination are met, and that the well is constructed in a manner such that its contamination cannot enter the well itself. So that's what I have there, and I think we're back to David.
All right, I'll start sharing again. hopefully. There we go. Okay, talk with you guys a little bit about plan review. This is my primary responsibility at the Department of Health, is to review the construction plans for any sort of drinking water infrastructure that is going to be installed. So our rule authority is listed there. Essentially what it says is that nobody can install or alter or extend a public water supply unless plans have been approved by the health department. And the one exemption that is specifically listed in that is for non-community wells. I don't know exactly when that lobbying effort happened, but at some point the well drillers got very tired of waiting for having hold up on their well drilling projects. So that came into the rule at that point. Here's some common plan types that we'd see. To give some perspective, water mains are the primary primary plan that we get submitted, probably in the range of 500 to 600 plans a year of various water mains throughout the state that are being installed in community systems. So I just do plan review for the community. We have a separate plan review for the non-community. And then we get maybe, 3-4 new treatment plants and maybe half a dozen to a dozen renovations of treatment plants, and probably similar for storage. And well, for whatever reason, this last year was kind of a well construction boom. That kind of caught me off guard there. But usually just, maybe 4 or 5 a year, but we got quite a few this last year. And then some chemical feed and well house plans we'll get in from time to time. One thing I did want to note that one of my colleagues mentioned that just for PCA's perspective might be useful is the treatment we see usually focuses on pathogen and contaminant removal, and it's usually pretty focused or targeted on one thing it's going to do. So when a system, suddenly starts having to treat for something new, usually they have to add a whole new treatment train to the process. And it's usually quite expensive to do so. I think the one app technology that tends to be the most of a catch-all is GAC, granular activated carbon. But even then, depending on what it is, its effectiveness and how quickly that would need to be changed out varies quite dramatically. And the other application that's gaining a lot of new headway is called advanced oxidation, and that's what those systems Brian was talking about that had advanced treatment have, where they use some combination of UV or ozone plus peroxide to create a very strong oxidant that will break down most chemicals. So when we review plans, we typically review them to the 10 state standards. Recommended standards for waterworks is what they're actually called, but almost everybody refers to them as 10 state standards. And it's referred to that way because it's a group of 9 states and a Canadian province that get together and write these. And Minnesota is one of those states. Brian spent a number of years being on that committee, as well as being the president of that committee for a while. And I think maybe for this most recent edition, and then I have stepped into that role just this last year. CEAM is City Engineers Association of Minnesota. We use them as a reference for a lot of our water main work, and then the plumbing code and the well code are also used where it's applicable. We have some agreements with DLI to do a little bit of plumbing review when it comes to like treatment plants and well houses and things like that, because we're seeing the plans already and it's something we're pretty familiar with. And Brian spent a number of years reviewing plumbing anyways, so it kind of seemed like a natural fit. So I wanted to talk a little bit as well about pilot studies. So we'd require a pilot study that's a small scale like a version of a treatment train or treatment system that they run and do tests on to verify that it works. We require them for newer technologies or newer applications of technologies. And our biggest rule is that the full scale design must mimic the pilot. We've had situations where they want, the pilot doesn't work that well, but they still want to go forward with something full scale. They don't want to waste the quote unquote waste the money, but it's still useful information. So they didn't waste money on a full scale design that won't work. And probably the biggest thing we've seen needing pilots lately is biological treatment. It's kind of a wastewater technology that's being managed and used for drinking water purposes. It's essentially letting the natural biology in the groundwater source develop, and it's typically used to break down ammonia. Ammonia isn't actually a contaminant that is regulated, but it causes a lot of treatment issues and stability issues in the distribution system. Or kind of going in the reverse direction, nitrate can be biologically treated to nitrogen gas. And I think, have the first one of those under construction right now in Cold Spring. So that'll be an interesting one. And sometimes during the plan review process, we'll refer to other agencies based on what's going on, like a gas chlorine room. We make sure that they check in with the local fire marshal, that the how they're setting that up is acceptable. Pollution Control Agency, refer to you guys a number of times, depending on the waste coming out of the treatment plant. If they're using lime softening, they'll have a lime sludge. I had one recently where they'll have backwash infiltration ponds, and they need to get that permitted through you guys, things like that. And the Department of Labor and Industry for OSHA and plumbing issues. And I'm gonna let Brian close here with some of our shared interests we have between us, and then we'll have some time for questions.
All right. Can you see that slide now, shared interests? Is that in?
I don't think you're sharing yet. Okay, it's starting to come up. There it is.
Okay.
There we go.
All right. So this part of the talk, we're going to talk about shared interests, and this is kind of where over the years we've seen where we've had common interests on projects between the MDH and MPCA. So typically it's going to be Superfund sites where there's contamination and possibly contamination in areas where the well capture zone is. So that earlier diagram that David had shown for the time travel of water for specific cities. So contamination sites and contamination plumes. I know I have a couple along Highway 100 area where they're trying to either manage or manage the shape or travel of the plume or shape of the plume by pumping water in a certain way and also being able to treat it either for use or putting it to the wastewater plants for treatment at wastewater. So we also have worked with your agency on petroleum spill and leak sites. I know probably about 10 years ago, I was seeing quite a few plans about communities that had to drill new wells because their community wells had been impacted by old leaky gas storage tanks from old service stations. So we've had common interests there. Existing and abandoned landfills where there might be leakage into the capture area again of the community water supply wells. And then the next one where it's discharges the wastewater treatment plants, it's twofold where you have waste discharge from a water treatment plant, whatever it may be. It could be anything from as basic as iron and manganese sludge to RO discharge, so you have salty waste, salty metal discharges, and also trying to solve the chloride problem in the chloride discharge permits that PCA issues. So as I said earlier, that I'm the chloride, I guess, contact person for MDH for drinking water systems. I also kind of work with the chloride folks at MPCA to make sure that they understand the implications of waste of water treatment and possibly centralized softening, but also looking at water softening in different realms on how it could impact cities' wastewater discharge permits. And then we also look at solid waste disposal. So I know back when I was doing plan review, we'd have radium and arsenic removal plants, and then also softening plants that use lime for softening. And those types of plants generate solid waste. So whether it be spent filter media or lime sludge that may contain certain contaminants that may or may not be regulated, we've tried to direct people that are proposing these plants to us to make sure that they get in touch with their MPCA contacts to make sure that this side of the equation is also taken care of. And then also discharges to water courses. So again, iron and manganese plants, we've had something as simple as an infiltration basin where they discharge their filter backwash water into a sandy area where the water bleeds, filtrates through, and the iron sludge and manganese sludge sits on top, and they have to periodically scrape that off and then deal with the sludge itself. We've also had projects that have had advanced treatment, reverse osmosis or similar type treatment, membrane filtration, where their discharge may go to a creek or stream or river. So we've tried to be good partners in the past, directing people to check in with the MPCA regulatory folks to make sure that any new treatment or water treatment plants or treatment schemes that cities are going to do, that they can also make sure they get permits on the other side of the coin, so the discharge or waste disposal side. So that's about all I had. We're willing to take questions on any of the information above. So thanks for the time to be able to present this, but let me know if we have any questions.
Yeah, if you have any questions, enter them into the chat, or we can unmute you too, and you can ask them directly to our speakers. Hey, thanks a lot, you guys. That was a great overview of the drinking water protection program, and interesting how many drinking water plants that you have to oversee with these different populations and different criteria. The different levels of community and non-community and groundwater and surface water sources.
Looks like we had a question about central softening at a drinking water treatment plant. There's essentially two ways, well, I guess three ways you can see central softening done. Either it can be done through like a home softener ion exchange, but on a much bigger scale, through lime softening or reverse osmosis. I know there's been some work done on this to see how well it affects the salty discharge to the waste stream issue, that if you soften it centrally, and the tricky part is convince your residents to get rid of their home softeners, then theoretically you should have reduced salty discharges. I know it's always I remember when I first started in the field, I had St. Peter, and they had recently gone to RO, and they had, I had many a letter from the local Culligan man in my file about his concerns and anger about them doing that. So there's always a fight involved when a city wants to do that. You still need a plan for a waste stream. With RO, you're going to have obviously going to have a pretty concentrated waste stream. With lime, the lime sludge can be disposed of a few different ways. I think that's when you're trying to get rid of the salty discharges. I think lime softening is generally what's preferred, but you do need the groundwater quality needs to be right for it, depending on what the hardness is. Sometimes lime is not effective. Brian, did you have anything to add to that?
Well, I was wondering if they had a specific question about softening at all.
The question was just, can you say more about the implications of centralized softening for drinking water?
Okay. So the implications are, it's what I usually tell people is soft water is great. And the reason I say that is I grew up in Minneapolis and I've had soft water almost my entire life. But it's a convenience to have that is fairly costly. So any of the softening mechanisms that you would use, so if it's lime softening, ion exchange, or RO, they can get fairly expensive for what we would say the perceived value is for that. So, you know, it's kind of a community decision whether they want that. It helps, you know, I guess people like it because it allows your clothes washer or your dishwasher, your dishwashing to have sudsy water. You know, there are benefits to it, but there are also trade-offs. So lime softening is the method that a lot of the larger systems use. It's a very effective system, but it's very labor and chemical intensive. And so some people don't want to have that level of involvement. And you also have to have an operator that knows what they're doing. And so not only that, so for the cities, they have to look at paying a skilled and qualified person to be able to run a plant of that nature. So
it sounds like Kathy is asking if is a problem for the drinking water distribution.
So from a distribution standpoint, softening. So what I like to tell people is that if you have a system that's currently not softening and you went to or we're evaluating looking at softened water. So anytime you destabilize the water or you strip the water of constituents that it comes naturally out of the ground with, you're going to make it in some way, shape, or form more aggressive. And so the other component softening that is kind of the not so obvious one is when you make a softened water, it does become more aggressive. So there are unintended consequences that you might have to deal with if you choose centralized softening. So for instance, you may create a lead and copper issue in that community because the water is more aggressive. You may touch off other potential contaminant issues that might come to light because of the softening process, just because of the nature of what's in the water originally. So there could be what I like to say unintended consequences or unanticipated consequences. So you'd really have to look into it to see if that is what I would say a potential can of worms that you would want to open.
Looked like there's a question about shallow groundwater sources and groundwater under the influence, such as Mankato, and how we approach that on the regulatory side. If it's groundwater, so like Mankato, groundwater under the influence, that would be treated just the same as surface water as far as a regulatory standpoint goes. once it's been determined to be under the influence of surface water. So I think there's a specific regulatory framework for that, because the groundwater is under the influence of surface water to some extent, but to actually be labeled as groundwater under the influence of surface water puts it into a surface water category as far as the regulations are concerned. I know we have an engineer who's kind of responsible for the surface water treatment rule, and I believe he's been putting together a group to evaluate potential groundwater under the influence of surface water wells out there.
Yeah, the work group has tried to establish a set of parameters on how to either classify or not classify groundwater under the direct influence of surface water. I know they've been working on that. It's highly controversial as far as the list of components that they look at. But there are some systems that are just obvious, Mankato being one of them, I guess. If the river's low, there's not a lot of water there, and if the river's high, there's lots of water there. So it's fairly obvious, but they are trying to make it more of a scientific evaluation of components of the water on how to deal with groundwater under the direct influence. And
it becomes a little...
to deal with the other part of the question where they talked about was it superficial aquifers or shallow aquifers?
Shallow groundwater.
Yeah, so at the health department, part of the source water group, what they do evaluate are community wells, and they rate the vulnerability of the wells, looking at geology. So if there's bedrock confinement or impenetrable areas of that could be considered confinement, such as clay layers in the drift material. They have a specific depth. I think it's 10 feet of clay is considered kind of what they would say would be a protected aquifer in a glacial drift setting. But yeah, again, the rule of thumb is the shallower the well, the more vulnerable it is. The deeper the well, the more protected it is. But also that goes along with that is the deeper the well, the potential more contaminants or things that you could run into. So what I have told people is in Minnesota, if you are on groundwater, you are going to find iron and manganese in your water almost 100% of the time. It's also going to be hard water. And how hard it is depends on where your geographical location would be. But again, as you go deeper, you might find arsenic and then also radionuclide issues that you're going to have to deal with. So it's kind of a trade-off, shallow versus deep. The other trade-off is the volume of water that you'll be able to draw, shallow versus deep. So there's a lot of decision making there.
Brian, this one might be for you. They asked, can we talk about blending local, probably groundwater from systems like Lewis and Clark or Lincoln Pipestone? And specifically towards corrosion control, that might be more complicated.
Right, yeah. So that is a very complicated issue to deal with. And so what they have to try to do is look at the two waters that are going to be blended to make sure there are not going to be any, what do you want to say, chemistry-based issues based on the mixing of those two waters. In this case, they pointed out Lewis and Clark and Lincoln Pipestone. Lincoln Pipestone's all groundwater. Lewis and Clark draws it from the Missouri River. They bring it up. I know they have a softening plant down there. So it is an art to be able to blend those two waters, manage the corrosion in the water, make sure that they meet their lead and copper requirements for sampling. And it's not an easy thing. I think the one that everybody knows about is the conversion of Flint, Michigan from one source to another. It kind of released a unbelievable amount of problems on that city. A lot of it was done as a cost-saving measure, and they ended up not really saving a lot of costs, but just spending the money in a different manner. But in Flint, they had massive lead and copper issues when they switched from one source to the other for economic reasons. But they also had Legionella issues based on that switch. And the other thing that's unfortunate is they probably also had some change in use patterns in Flint that also helped contribute to the problem, just because that was Flint was known as also a car manufacturing city, and with car manufacturing being down probably 10, 15 years ago, the water draw from the city residents probably wasn't as high because a lot of them moved out, similar to what happened in Detroit. And so there's a lot of things that contributed to that. But locally here, the city of Bloomington buys Minneapolis water. So Minneapolis is a surface water from the Mississippi River. Bloomington pumps their own wells, and they augment or supplement their water from their wells with water from the city of Minneapolis. Again, it's groundwater and surface water. So they try to match each other's water from a disinfectant standpoint. They also look at other chemistry issues, but they don't. Bloomington has not had any issues, as far as I know, with that blend. So as long as you are paying attention to the chemistry related to that and you acknowledge that, it is possible to deal with it. So.
Yeah, and I know I've seen a few projects where a system's going to be hooking up to either Lincoln Pipestone or Lewis and Clark, and they are changing their disinfectant approach to match the incoming water. And whenever they make a change like that or hook up to a new system, their monitoring schedule for specifically lead and copper, because of the corrosion potentials, gets essentially reset to base level. So I think it's every 3 or 6 months they're taking lead and copper samples, and we start right after they make the switch. And they need to do that, I think, for 3 years until they can show that it's not causing significant problems.
Go ahead and ask your question, Elise.
Yeah, Elise, you have your hand up. I don't know if you intended to have it up or not.
Yes, I did. I just want to ask a question, and that's just about the nature of the work that Department of Health does. You guys don't write permits, correct?
That is correct.
Okay, and so when you have a community that does something that you didn't approve or you didn't review, what action can you take? Is it under that Minnesota Rule 47? Yes, 4720. Yeah, yep. Is it that? Okay.
Yes, it is.
Yeah, so that rule really outlines it outlines basically what they can and can't do. And in a nutshell, what it says is you can't build a water system, you can't add on to a water system, you can't modify a water system that serves I think in the rule it says considerable number of persons, which we'll take as either non-community or community, without the commissioner's permission. And so when I was in plan review, and now David, he is the commissioner's representative as far as being able to review and approve those things. For cities, we have had cities that do improvements without telling us. And so in the past, we've done administrative penalty orders to get compliance. So they might have to submit as-built on what they did. They may pay a financial fine, a penalty as part of that, because ignorance of the law is not a reason to not observe the law. But anything that they may have done in that project, if it's required that it be modified to meet the minimum requirements that we have, they have to fix it. And so that rule gives us the ability to enforce that.
Yeah, we've had that happen a few times. Usually it's not, pretty rarely they have to make big fixes. Usually it's just a small fix or two, and then there's a fine, and I don't think we've had repeat offenders on that.
The biggest issue for most people is the public shaming.
So I have a question for the two of you. Now, looking forward and based on your experience with all of this, what do you think are the biggest challenges coming our way in drinking water treatment plants? What are the issues you see coming our way that you think are going to be, the biggest concerns?
Well, for me, I think the biggest challenge is for people that, so the users of the water systems, and for what I usually say, the complainers, the people that complain about what they're paying for the water to buy the water to use it. Maybe they should think about polluting it, because it costs an incredible amount of money to clean up polluted water, as a lot of you guys already know. But also from a drinking water standpoint, to make it drinkable, it is unbelievably expensive. And so if people would realize that preventing pollution is a lot cheaper than trying to fix it once it's been done, that would be probably the big issue right now.
I think similarly the cost, and also like the communication challenge with understanding risk, that it's really hard to define what is safe, but we really like the word safe and want to use it. And but there comes an element of, it can cost a lot to drop a certain contaminant from 0.5 to 0.3. And is that worth the community spending an extra $10 million? And how many more people are going to be at risk of what if you don't? And I don't know at what point we're going to get to that where it's just not sustainable, like financially, to always treat to the lowest level we can detect, or things like that.
All right. Well, thank you guys very much for joining us today and sharing your important work with us. We really appreciate you taking time out to be here and talk with all of us.
Yeah, that was a great talk. Thanks.
Thanks for the opportunity.
Yeah, thank you.
Yeah, so I think that does it for today. Thanks everyone who was able to be here with us, and we will see you on February 11th for another great talk. So please join us, and we look forward to seeing all of you again.
Yeah, our next talk is going to be from, like Brooke said, February 11th, Eric Dahl from the Environmental Quality Board, and Suzanne Reese from Bowser is going to talk about the state water plan, specifically about how climate is changing that state water plan. That should be an interesting talk as well.